Welcome to the Simplified Runtime Governance demo for Fuse ServiceWorks version 6. I'm Kenny Peoples, the JBoss Technology Evangelist for Fuse ServiceWorks, as well as Data Virtualization, Fuse, and AMQ. So let's first talk about the runtime governance components. We have the activity collector that's used to collect activity events. We have the activity store and server used for central activity event storage and querying. We have the event processor network that's used for generic analysis to process the activity events. And we have the activity collections used for active information management to post-process and cache information for end-user applications. So let's talk some about the activity collector. The activity collector component of the architecture is optional and is responsible for collecting information from the execution infrastructure as efficiently as possible. It collects the activity events associated with a particular thread as a group contained within an activity unit. This provides an implicit correlation of the activities that are associated with the same business transaction. You may also pre-process the activity events to extract relevant context and property information before it is reported to the activity server. Activity units are then batched into further groups and reported to the activity server at regular time intervals or when the batch gets too large. The activity collector and activity server are co-located with the same execution environment. The activity units are reported directly. If the activity server is running remotely, then you can use suitable connectors to report the information via the REST API. So the activity server provides a public API for reporting a list of activity units. Remote components can access this API either directly, for example, CDI component, or remotely via REST. The activity server has the following main responsibilities: to ensure IDs are set and consistent, to store the events in a repository, and to notify other interested modules. So the event processor network, the activity server notifies the event processor node about the activity events through the event processor network. The runtime governance infrastructure notifies one or more event processor networks, specifically event processor networks that have a subscription for the subject activity units, about activity events reported to the activity server. Each event processor node defines the following: an optional predicate to determine whether the event is of interest, and an event processor to perform the actual task of event processing. The processors can be specified using Java, Drupal, CP rules, and MVEL. So now the active collection mechanism provides a capability for stored processed events and derived analysis information in a manner that the end user can access. It also notifies the end users or applications when any changes occur. Of course, components can directly access these collections or issue queries through the REST API. So the gadgets, the runtime governance information is provided through a set of gadgets in the web UI, as well as the information can be pulled through, as we indicated, REST APIs and responses received. So the service response time gadget, this should contain the response time information based on the business transactions executed while the server has been running. The gadget configuration allows filtering by service types and operations. The list of service types and operations are currently obtained from an active collection whose contents expires after a short period of time, and therefore these drop-down lists may only contain all if no other information is currently available. The service let's see. Okay. There it is. So the situations gadget represents information of interest to end users. This is a generic concept that can be used by custom policies, rules to report alerts, notifications, information to users. When the situations appear in the list, you can expand the details arrow to see more details about each one. This information is derived from the underlying activity events that caused it. Then we have the call trace gadget. The final, this gadget allows the call trace to be displayed for a particular business transaction instance. Currently, this is limited to transactions that have a conversation ID. The service overview gadget, while trying out the situations gadget, you'll see that the service overview diagram associated with the business transaction being performed. It is color-coded to reflect services that have performance issues. If you expand the gadget using the line with an arrow at each end symbol, then you can see more information, including hovering over the various elements to see metrics. So with our demo, we're going to have 4 different demos that we're going to run through. Synchronous policy, asynchronous policy, service level agreement monitoring, and service level agreement reporting. So the synchronous policy example, this synchronous enforcement approach shows how a business policy can be implemented in a synchronous or inline manner where the decision is taken immediately and can therefore be used to influence the current business transaction. The benefit of this approach is that it ensures only valid transactions are permitted, as decisions can be immediately enforced. However, the disadvantage is the potential performance impact this may have on the business transaction. This example shows activity event analysis using the activity validator mechanism to implement the business policy. So this demonstration example demonstrates how a policy enforcement mechanism can be provided using the activity validator mechanism to immediately evaluate the business policy and, if appropriate, block the business transaction. So in our demonstration, if an order message is sent twice in less than 2 seconds, an error will result and the business transaction will be blocked. So for the asynchronous policy example, the asynchronous enforcement approach shows how a business policy can be implemented in an asynchronous or out-of-band manner where the decision is taken after the fact and can therefore only be used to influence future business transactions. The benefit of this approach is that the decision-making process does not have to occur immediately and therefore avoids potentially impacting the performance of the business transaction. The disadvantage is that it does not permit any decision that is made to be enforced immediately. This example shows that the activity event analysis using the event processor network mechanism can be used to implement business policies. Results from the business policies can be cached for reference by other application platforms. Specific interceptors can reference the results to impact the behavior of the business transaction. For example, prevent suspending customers purchasing further items. So with our asynchronous policy example, it demonstrates how a policy enforcement mechanism can be provided using a combination of the runtime governance infrastructure and platform-specific interceptors. Our example uses an asynchronous approach to evaluate the business policies, only enforcing the policy based on a summary result from the decision-making process. The benefit of this approach is that it can be more efficient and reduce the performance impact on the business transaction being policed. The disadvantage is that the decisions are made after the fact, hence it leaves a small window of opportunity for valid transactions to be performed. So our SLA monitoring example, SLA monitor, this monitors activity event analysis using the event processor network mechanism. It can be used to implement service level agreements using the complex event processing, just CEP, based event processor using Joule's Fusion. Impending or actual SLA violations, the service level agreement violations, can be reported for the attention of end users via the JMX Notifications REST service to build a custom application to access the analysis results. Our example shows a simple service level agreement that checks whether service response time exceeds expected levels. The CEP rule detects whether a situation of interest has occurred, and if so, creates a situation object and initializes it with the appropriate description or severity information before forwarding it back to the event processor network. This results in the situation object being published as a notification on the situation subject. Our example for SLA monitoring demonstrates how service level agreements can be policed using rules defined in an event processor network and reporting to end users using the pre-configured situations active collection. The rule used in this example is detected whether the response time associated with an operation on a service exceeds a particular level. However, more complex temporal rules could be defined to identify the latency between any 2 points in the business transaction flow. Our SLA reporting example demonstrates how to provide pluggable reports that can access information in the activity store. The example uses the activity information to compile a service level agreement report highlighting violations above a specified response time. So our example shows how to configure a pluggable report, how to generate the report via REST API, and it provides a service level agreement report based on identifying service invocations that exceed our specified maximum response time over an optionally specified average duration. Of course, if the average duration is not specified, then each service invocation is checked to determine if it exceeded the maximum response time. If so, it gets added to the report. If the average duration is specified, then when an invocation is detected that exceeds the max response time, then all other suitable invocations within the specified duration are averaged to determine if the response time overall still exceeds the specified maximum. This is to ensure the periodic spikes are not unnecessarily reported. It is also possible to optionally specify a business calendar, which can be used to determine the business period in which activities are of interest. If SLA violations occur outside the specified business calendar, then they are not relevant. So our example demonstrates how the report definitions can be deployed to the runtime governance infrastructure and invoked to generate the report instance via a REST service. So as you can see, runtime governance, very powerful. The next videos will show how to run the demos. So thank you.